Well, hello guys and gals, Mike here, welcome back to my channel. Time for another Hacking on the NABU video. You know, my goal after I got the NABU was to make it a standalone computer, since it was made to work over a network. The network doesn't exist anymore. Yes, some people are rebuilding it. But you know what, I kind of like the old standalone computers back in the late 70s, early 80s. They were cool, okay? And you could just turn them on and go. You know, you didn't have to connect to a network. You didn't have to pay somebody for a subscription. If you wanted to sit down and hack around in BASIC, all you had to do is hook up to a TV and turn on your computer, and you were good to go. And that's what I've been trying to do with the NABU. There's been some serious progress in that direction since the last video. Now, at the end of the last video, I teased something. I teased the idea of making my NABU able to access 32K of EEPROM or EEPROM. How is this possible, you ask? Because the NABU stock can only handle 4K. With a minor modification, it can handle 8K. It can't handle 32K. Mine can now. I've made another modification. And we'll talk about that, how I did that in this video. But how about a little demonstration of what you can do with a NABU that has 32K of EEPROM in it. Alright? Before, it would boot to my monitor, which if I do a cold start, it will still boot to my monitor that I've written for the NABU. Now, before, if I wanted to run BASIC, I would have to import it over the HCCA interface from my laptop over there. Well, there's the HCC interface cable, the RS422 converter. It's not plugged in. The NABU is standalone. But what happens if I hit BASIC now? Hit B for BASIC. Oh, look at that. Cold or warm start. Yeah, we'll do cold start. Memory top. Hey, we're in BASIC. Just that simple, because it's all in EEPROM already, or EEPROM. It's there already, and I'm not even using up half the space of my 32K EEPROM. I could put a lot of other stuff in there. What I have implemented here is a bank switching technique for the EEPROM using unused aspects of the existing NABU hardware. I'll explain how that works in a bit. So I've got my monitor here, which takes up a little over 4K, and I've got BASIC, which takes up almost 8K, in a 28C256 EEPROM in there. So, it's a beautiful thing. We're very close to having my standalone NABU. We just plug it into a TV, you turn it on, and you're ready to hack away in BASIC. It's not quite 100% there yet. Still having a few issues. Let me show you how I got this far. So my NABU now has access to the full 32K of EEPROM in this 28C256 EEPROM. How is this possible, you ask? Yes, there's a modification you could make to allow your NABU to access up to 8K of EEPROM or EEPROM, and I have made that modification finally. So that should limit me to only 8K, correct? Well, not exactly. I have my EEPROM in a 0 insertion 4 socket, which is standing off of the EEPROM socket down there on the motherboard with some headers. And what I have done is I've bent 2 pins outwards so that they do not go into the socket. Pin 1 and pin 26. Now these pins don't really do anything on the NABU because they correspond to pin 26 here is address line 13 and pin 1 over here is address line 14. Well, these are not run out to the EEPROM socket anyway on the NABU because you can't run more than 8K of ROM on the NABU, so you don't need those higher order address bits. But what I'm doing is I'm running them over here to U6. U6 is the control register. And the NABU designers cleverly left us 2 unused output bits on the control register. Well, I can use those to write out address values for my bigger EEPROM. So basically what I can do here is I can get 4 banks of 8K this way. So that 4 banks of 8K equals 32K, which is the entire capacity of this 28C256. So that's how I'm doing it. And let me show you some stuff on the schematic and show you how this works. So here's our 28C64, which I've been using up till now. And you can see over here, pin 26, no connection. Over here, pin 26, A13 on the 28C256. Over here, pin 1, no connection. But over here in the 28C256, we've got A14. So all I really needed to do was find access to signals that I could use for A13 and A14, and I can use the entire 32K chip. So I'm looking at the NABU schematic, and right there, U6, control register. Look at that. All 8 bytes of the data bus are going in, but they're only using 6 of them. We've got 2 unused lines right there, 2 unused outputs that we can use to put address data on our larger EEPROM. So I've just got some little micro test clips hooked onto the outputs on that 74273 control register, and I'm running them to the bent out legs on the headers that I've soldered onto the bottom of my ZIF socket. And presto, I've got bank switched EEPROM for the NABU. So let me give you a look at the code for how I have done this, how I've implemented bank switching on the EEPROM in the NABU. And this code needs to be cleaned up a little bit before it's released. It might come out about the same time this video does. We'll see. Okay, guys, hold the phone. News from the future. I have had a couple of brainstorms about cleaning up some problems I have with text editing in BASIC. So I'm going to delay releasing this version of the firmware for now until I get that cleaned up, because I think I can fix that. It's looking really promising. So watch for another video in the not too distant future and the firmware release where basically everything's going to work, okay? This video is mainly about the hardware modifications I've made. The next video will be about firmware improvements and fully functioning BASIC interpreter, okay? And that should be coming along really soon because I'm making good progress. I just don't want to release some half-baked code when I know in a few days or a week at the most I can release something that's going to work a whole lot better. Back to your regularly scheduled video. But I think I've done something clever here. The very first thing we do, the very first thing we do is disable interrupts, okay? Up here at the top. And then the very next thing we do is jump to a program called Move to RAM. And it does basically what it says. It's going to copy ROM to RAM and restart. This jump gets overwritten with NOPs in RAM. So let me show you how I implement that. If we go all the way down to the bottom of the code, and the code is quite long because I put all 256 of the characters for the character set back in because I've got plenty of room in the EEPROM now. So we go all the way back down to the bottom. This gets called, first thing, move to RAM. So this is going to move the contents of ROM to RAM and then disable ROM and restart. So what this does is, this is a very simple little program, and all it does is it moves the procedure copy ROM, moves it into the upper half of RAM, above 32K. So it just copies this. And there's like 2A hex bytes there, I think. And then it jumps to it. And this is relocatable code. Basically, once this is compiled, this can be put anywhere in memory and run from there without any problem. There's no absolute addressing involved. It can just, run from anywhere. And what this code does is it's going to start loading the different pages of the EEPROM into RAM memory. Because remember, we can read from the EEPROM when it's enabled and write to the RAM. We just can't read from the RAM or write to the EEPROM. So we can copy the contents of the EEPROM into RAM at the same location. So what copy ROM does is this is gonna reside in the upper half of RAM and above 32K basically, so that we could load the entire 32K EEPROM into RAM if we wanted to. Now I'm not doing that here because I don't need to load all 32K. So in the lower 8K of the EEPROM is my monitor, and in the next upper 8K is Grant Searle's BASIC. So what this program does is it's going to start copying the lower 8K of EEPROM into RAM, and we're going to be on the lower 8K because the NABU, the control registers on the NABU are all zeros when the machine resets or restarts. So it's only going to point to the lower 8K. The A13 and A14 lines are going to be low. So we're going to point to the lower 8K. It's going to copy that into RAM. And then it's going to write 40H to the control register. And that will let us copy the first bank, or bank 1. We've got bank 0 here. We'll copy bank 1 next. That's the second 8K bank of EEPROM. We'll copy that into RAM above the monitor. And then here I could actually copy up to 2 more pages out if I wanted to, but I don't need to. But that's reserved for the future, because I might need to in the future, or I might want to have something besides BASIC in one of those banks and write that out. And then what we're going to do is we're going to overwrite the call, or actually the jump to move to RAM. We're going to overwrite that with NOPS, no operations. And if you remember, go all the way back up here to the top, almost the top. One of the first instructions to be called is move to RAM. Well, this is a 3-byte instruction. It's got the jump instruction, and then it's got 2 bytes for the address. Well, we're just going to overwrite those 3 bytes with NOPS. And the machine, when it runs, will just skip right over them and come up to the next sets of instructions in RAM. So we're doing this in RAM so that when we restart out of the RAM, we don't have to execute this instruction. We just wind up in a stupid loop. So we don't want to do that. So we'll overwrite that with NOPS. Come back down here. So after we've overwritten everything with NOPS, we are going to write out another number to the control register, 01 hex, and what that's going to do is just going to disable the ROM, turn it off. So it's a completely RAM system now, but we're executing out of RAM, so we're not going to get lost because we're executing out of the upper RAM here. And then the next instruction is jump to 0, and so that's going to restart the system. So it's going to come all the way back here, and it's going to restart over here at 0 and work its way down, but this instruction isn't here anymore. It's been overwritten, so we're going to go right into the monitor. So I think that's a fairly clever way of doing it, if I do say so myself, and it seems to work pretty well. And there is room for growth in the future. Like I say, I'm not even quite using half of the EEPROM there. I've got 2 full banks that I haven't even touched yet, and my monitor program is only using about half of 1 bank, a little over half of 1 bank. So there's a lot of room for growth there yet. I can cram a lot more stuff into the NABU if I want to. So yeah, I know the modifications I made here to the NABU, hardware and software, aren't for everybody. I understand that. But if you are interested in having a standalone NABU, it's not that difficult to implement, okay? And there's going to be a list of the parts I use in the description of the video down below. So you can pick them up too if you want to do the same thing I've done here. It's pretty darn simple hardware-wise, all right? It's not rocket surgery. So, yeah, like I say, it's not for everybody, but if it's for you, I hope this helps. You know, if you're interested in having a standalone NABU with software built in ROM, you just plug it into your TV, flip the switch, turn it on, and you're good to go. Then I hope this helps. I hope you find this interesting. Down the road, I want to add some other stuff. I want to add mass storage too, so we can save the software we create on the NABU and bring it back in. Whether that's going to be like old school floppy disks, I don't know. It might be newfangled CF card or SD card storage or something else. Who knows? But yeah, mass storage is coming. CPM operating system down the road, way down the road maybe, but it's coming. So, you know, I'm making good progress, I think. So, like I say, if this is interesting to you, if this is helpful to you, give the video a like, give it a thumbs up, and subscribe to see my future NABU hacking videos. And check out my main channel, Omega Geek 64. There's good, interesting stuff going on over there every day if you're interested in recycling e-waste and recovering the precious metals from it. That's what I do over there on my main channel. And I will see you in the next video. Thanks a lot for watching this one. Bye.